Hello everybody, today we're going to look at this problem from the AMC. The real number x satisfies the equation x plus its reciprocal equals the square root of 5, and then you're asked to evaluate this polynomial here. Now, naively, what you might expect to do is to write out this first equation, and then turn it into a quadratic, so multiply everything by x, move everything over to one side, root 5x equals x squared minus square root of 5x plus 1 equals 0, and then maybe use a quadratic formula or something like that, and then you're going to end up with this extreme radical form for x, which you would then substitute back into this. Now, this is absolutely not what you are supposed to do. Do not do this. It takes way too much time. There's far too many things that can go wrong, and you're going to miss the sort of bigger picture here. So let's have a look. So this equation, x plus 1 over x equals square root of 5, has some interesting symmetries. So let's have a look into them. So there's a couple of hints here in the question. The fact that it's a square root is basically begging to be squared. And then if you realize that if you were to square this, an x multiplied by the 1 over x would cancel in some way. So let's just see what happens when we square both sides. So I'll just square the right hand side. But we'll do the left-hand side manually. So when we multiply x by x, we're going to get x squared. When we do x times 1 over x, we're going to get 1, and then the other way around, 1 over x times x is 1, and then plus 1 over x squared equals 5. And if you tidy this up, you get x squared plus 1 over x squared equals 3. Now this is kind of interesting because it's very much of the same form as the problem that we started with. So let's just see what happens if we do this once more. So let's just square both sides again. 1 over x squared plus 1 over x squared equals 9. We're going to get that 2 popping out again. It always pops out. You get x to the 4 plus 2 plus 1 over x to the 4 equals 9, and then you get x to the 4 plus 1 over x to the 4 equals 7. All right, and then the last thing we're going to have is we're going to have x to the 4 minus 7 plus 1 over x to the 4 equals 0. And that's as far as we will go for now. You'll see why I stopped there later. But once again, when we do it for the 4th time, you always get something out of the same form. You get x plus its reciprocal is this, x plus its the square of x plus its reciprocal is this, and then its 4th power. And you're going to get increasing integers at this point. You can work out what the next one will be. I believe it will be 47, but you can prove that. So why should we care about this? Well, let's now look at the polynomial. So at first, this polynomial really doesn't seem to have much to do with what I've been doing down the left-hand side. But let's have a look at factorizing it. Now, you might be tempted first to factorize like this. Just take out the x to the 3, sorry. Take out the x to the 3, and you'll be left with this. And then you have a quadratic that you need to solve. But you'll quickly notice that this quadratic doesn't have any neat integer factorization. So what if we were to actually divide by another power of x? In fact, divide by x to the power of 4. So we'll take this out, and you're going to see why this is so useful. Now, the thing on the left just becomes x to the 7, and that thing on the right might start looking quite familiar to you. Let's have a look. That thing on the right is just what we had down here. So what does that mean? Well, it means that whole left-hand side just becomes 0. So we've got x to the 7 times by 0. It doesn't matter what x to the 7 is. The answer to this is 0. All right, so just quick recap. We use the symmetry in this kind of equation to generate powers in the expansion. And then you need to recognize that whenever you have a quadratic, there's a hidden quadratic, we've got 8, 4, and then there's a 0 there. You can actually divide through by x to the 4, the middle term, and it will turn into this sort of value in the middle, power, and then reciprocal expression, which then hopefully will look something like one of these. If you found this helpful or interesting, please hit the like button, let me know your thoughts in the comments below, and of course subscribe so you won't miss the next video.